Speed in meters per second of a car approaching a stop sign is shown in the graph below and can be modelled by the equation v of t is 6 multiplied by 1 plus cos 0.25t plus sine squared 0.25t, where t represents the time in seconds, and beware here, we must have the calculator in radian mode. In the table below, which we've got to complete, we can see this is 3.34, and you should always check that you get 3.34 when you use 10 for t. So, since we're going to be doing this a lot of times, let's type it in. And I'm going to start off using the 10. Now, I'm in degrees at the moment, so I need to make sure I change to radians. So we've got 6, open bracket. Then we've got 1 plus cos 0.25, and let's multiply that by 10, and then plus sine squared. Now, in order to do that, I'm going to put a bracket, then we're going to do sine 0.25 multiplied by 10. Close that bracket, close the bracket around the sine, and then square that. Remember what sine squared means. And then we'll close the bracket around that. If I execute, 3.34 is what I get. Okay, so let's fill in the rest of the table. So starting with the table, we need to change that 10 to 0. And that gives us 12. So in here we're going to have 12. We then need to change that to 2.5. And that's 12.92. We can see the shape up here, so we can check that that's reasonably consistent with it. Then we need to change to 5. $13.30, and then finally 7.5. And make sure we change that in both places. That gives us 9.66. Complete the following table and hence estimate the distance travelled by the car during the first 10 seconds by calculating the mean of the sums of the inscribed areas and the circumscribed areas using 4 rectangles of width 2.5 seconds. Now once again in the table here we can see they've given us the calculations. Now this 8.35 I think uses this rectangle, so it's using the height at 10. So let's just try that. So the width of that is 2.5, so we're doing 2.5 multiplied by 3.34, and that does give us 8.35. And then here for the circumscribed, I think they're using this rectangle, so they're using the height at 7.5, so 2.5 multiplied by 9.66 gives us 24.15. So that means that this must be 24.15, because when we use the rectangles here, that would be the height of that one, and then there'll be another rectangle just there, which is going to use the height of 5. So 2.5 multiplied by 13.3, that's 33.25. Now the shape might make a difference here, so let's just look at what this is like at 2.5. So 2.5, the height is this, at 5 the height is this. So it looks like for this one they change over. And so 2.5 would be the value at 2.5 would be the inscribed. So that's going to be 2.5 multiplied by 12.92 gives us 32.3. So that's this one. And this bit, that one would be the circumscribed. So this one is 32.3. And then, so for this one here, the inscribed area is going to use the 12. So this one would be 30 exactly. And for this last value here, we can see that's going to be the same height as the one next to it. So that's going to be 33.25 as well. So if we do the inscribed area, it's a case of just adding up those rectangles. So 30 plus 32.3 plus 24.15 plus 8.35. That gives us 94.8. The circumscribed area is going to be 32.3 plus 33.25, and there's two of those, and 24.15. So that gives us 122.95. And so distance, we're told, was supposed to be the mean of those. So we're going to add them. Oops, probably should have just typed it in. And divide that by 2. Gives us 108.9, we'll say, to one decimal place. And distance, so the distance, I don't see any units somewhere, so I'm probably just missing that. I don't want to spend ages in this video looking for it, but if there's units here somewhere, we should use them. Suggest one change. Apparently this says meters, but I can't find it anywhere in the question, so I wouldn't penalise the mark for that. Suggest one change to the above procedure to improve the accuracy of the estimate. Well, it's always more rectangles. The more rectangles you take, the better it is. And when you take an infinite number of rectangles, you're doing integration.